battery not disconnected or battery is in connection. T equals to D, right? Number one, this is the diagram. Battery in connection, dielectric is introduced. This is positive charges. Here you have negative charges. Let's say this is V0. So V0 is the voltage before you put the dielectric, and also you are not changing the battery voltage, battery is still in connection. So as usual we told these things: C0, V0, Q0, U0, E0. All these things before you introduce dielectric. These are the things, the subscript 0 or the subscript naught, V0, Q0, etc. These things will be after you introduce the dielectric. Here capital letter U represents energy, before and after, before and after, before and after. After means after you introduce the dielectric. Understood that? So here, because first case, effect on PD. Effect on PD. What do you think the effect on PD should be? It has to remain same because battery is not removed. Battery is still in connection. So these two are as if they are now in parallel. This is V0, that has to be V0. So voltage across the capacitor will be same as the applied voltage. So V is equal to V0. V is equal to V0. There is no PD, there is no change in PD. Potential difference, you write in words also, the potential difference remains same. No change in the potential difference. Okay. Number 2, effect on electric field. Effect on electric field. Electric field. What formula we have? Electric field and potential difference connection. For that, E is V by D. Do you remember in parallel plate capacitor? So E is V by D. That is, this is D. That is thickness of the dielectric. D, and also it is T, because we have taken the case T equal to D. Currently we are discussing T equal to D. So electric field here will be V by D inside. So this is E0 is V0 by D and E is V by D, because T equal to D, don't forget it. Therefore E by E0 is V by D into D by V0, D cancel. So E by E0 is V by V0, but we already proved V equal to V0. So this will be 1, so E is equal to E0. Electric field should remain same. That is, there is no change in the electric field. V is equal to V0 and E is equal to E0, there is no change in the electric field. You see, this one is something unexpected. Why do you say this is unexpected? Because whenever there is a dielectric, electric field should decrease, because dielectric polarization will take place. Here you will have negative charges, here you will have positive charges. Okay. Therefore dielectric polarization will have to take place. If dielectric polarization takes place, net electric field will be less. than the earlier electric field, beginning electric field. But here we are getting E is equal to E naught. So this is something unexpected. Electric field does not change even inside a dielectric. Without the dielectric, whatever was the electric field, same is the electric field even you put the dielectric inside that dielectric. So this is something unexpected. But it is coming like this. E is equal to E naught. So actually what is happening, E is equal, because we have not used any wrong formula here. We are only using E is equal to V by D. That is correct only for the parallel plate capacitor when we talk about the electric field inside the parallel plate capacitor after you put the dielectric. So what is happening, the moment you start introducing the dielectric, because the battery is in connection, it will draw more charges because the supplier of charges are there in connection. Earlier battery was removed, therefore charges cannot be changed, but here there is a provision for the charges to change. So as you insert, there is a possibility of more charges. So here we expect the electric field should decrease, but it is not decreasing. So what is happening, as you start introducing the dielectric, there may be more charges drawn from the battery. With respect to the more charges go from the battery, electric field will be more, but because of dielectric, from the more electric field it will become less electric field. So balancing, the electric field will remain same. Have you understood this idea? Otherwise electric field should definitely decrease. So that you can do it by discussing about what happens to the charge. So the next one is effect on charge. Effect on charge. Effect on charge. Charge means charge on the capacitor plate. Okay. So let's say that this is E naught. E naught is sigma by epsilon naught is the formula for the electric field inside a parallel plate capacitor. E naught is sigma by epsilon naught. So Q naught by A epsilon naught. Then after you introduce the dielectric, E is equal to, now there will be more charges, more or less, some charges will be there. Let us assume that some change in charges because battery is there in connection. So let's say new charge is Q1 after you put the dielectric. So for that Q1, assuming Q1 charge in the dielectric, electric field will be A epsilon naught epsilon R. Is it all right? Please tell me if you have, or ask me if you have any question. Because dielectric. Understand that. So dielectric field has decreased, but with a new charge collected on the plate. But we already proved that E is equal to E naught. Therefore, Q naught by A epsilon naught is equal to Q1 by A epsilon naught epsilon R. A epsilon naught will cancel. So what is happening now? Which indicates Q1 is equal to epsilon R times Q naught. Instead of epsilon naught, you can even write K in this context. If I write K there, you may get confused with that K 9 into 10 power 9 which is used in Coulomb's law. But here K is dielectric constant. So what is the inference? Charge increases by a factor dielectric constant of the medium. Dielectric constant of the medium. So for more charges, more electric field, then because of the dielectric, less electric field, overall effect is no change in electric field. Is it understood? Then what is the next one? Effect on electric field, everything is capacitance. Okay. Effect on capacitance. Note that all these things T equal to D. On capacitance. Other things will be easier. Only here you will have to think a little and do other things. C naught is Q naught by V naught. C is Q by V. Therefore, C by C naught is Q by V into V naught by Q naught. This Q only we said as Q1. We put Q1 there. So I just make it Q1 because we assumed Q1. Okay, let's say this Q1. Of course, which only we took earlier as Q. So Q is equal to Q1. I put Q1 there. So here Q should come, but Q is equal to Q1 you can take. So V naught by Q naught, but we said V is equal to V naught, you can cancel. Then what is this Q by Q naught? That means Q1 by Q naught. Q1 by Q naught will be epsilon R or K. Therefore, C is equal to epsilon R times C naught. Increases. Do you remember I told at the beginning capacitance will always increase? Okay? So, capacitance increases, potential difference remains same, charge increases, electric field remains same. Next is energy, effect on energy. Effect on energy. U is equal to, here it's better you use the expression of CV square because V is constant, it will be easy to compare. So U is half CV square, U naught is half C naught V naught square. So U by U naught half CV square by half C naught V naught square, half cancel, V square V naught square will cancel. So C by C naught is epsilon R. Therefore, U is equal to epsilon R times U naught or K times U naught or K times U naught. K dielectric constant. Understood? So if you know the method, you can easily derive all these things. This is the case when T equal to D.